So the primary purpose of this project is mentioned here. The reason why we have worked on this project is because we think it's important to identify the issues so that we can actually address it and probably even help to minimize these issues. And another thing is, in the contemporary world, there are many studies that are being carried out on human mortality rate. However, those studies tend to overlook the tiny factors that actually affect the human mortality rate. It could be just 0.1%, but it still counts. So we have included most of such factors in our datasets, and we have then worked on Spark and coding and stuff. And we aim to spread awareness, like for example, this lecture here probably spread some awareness among you guys. And so we just want to contribute to the good cause. I think it's our responsibility to care for the system. This is the purpose of our project.
Yeah, when it comes to our data set, first of all, our data set is very huge and it cannot be handled by the conventional systems and the traditional software package which we have till now. So in terms of the software stack, you can see earlier we used to use Excel or databases or different other tools to handle the huge volume of data. But our data simply cannot be handled by Excel. So if you open the file in Excel, so it will simply crash. So the only way to do computation on this data is with the help of Bigdata or Hadoop. So which are the topmost big data frameworks currently in the market. And so the question what we came across is why we are going to Apache Spark, why not Hadoop or any other big data framework. So at this point of time, when it comes to the performance, so Apache Spark is top in terms of performance. Within the documentation of Apache Spark website, we can see that Apache Spark is 100 times faster than the Hadoop framework. So why this speed is because of the in-memory computation. Apache Spark supports the in-memory computation. All the data operations, transformations, everything is done within the in-memory. And second point is ease of use. I'll also go through all these points on a high level, so this will be a quick overview. So you can see these are the main points: ease of use, data processing, security, fault tolerance, and multilingual. So when it comes to performance, as you can see, Hadoop has this map-reduce architecture, which is very famous, and Hadoop actually came into existence in 2005. Yeah, it was founded in 2005, but it became open source and it gained the popularity in 2010 with the help of the map-reduce architecture and technique or methodology. And as part of map-reduce, you can see we have different databases, and we divide our data in terms of chunks and load the chunks to the RAM, and then once we get the output with the help of lineation technique or any map-reduce technique, then we again store the result into the secondary storage back again. So that's what is done in the Hadoop framework. But when it comes to the Apache Spark, you can see the intermediate layer is also again RAM, as well as the result storage part is also again RAM. So this is very fast. Let's assume if we have 100 GB of data and we want to process that data with the help of Apache Spark, then Apache Spark will simply divide the data into small chunks and then load each chunk into the RAM, and then process the data and then store the data and reduce the data and then store the data again into RAM. So that's why Apache Spark is very faster, and so that's why we have implemented our project with the help of Apache Spark. Second point is Hadoop uses only Java, the only language through which we can interact with the Hadoop is the help of Java. But when it comes to Spark, we have this Python, Scala, and Java. Spark is natively written in Scala, but we have high-level APIs for Python as well as Java. So it is somewhat flexible when it comes to Apache Spark, because most of the people may know Python or Java, so they can easily scale up with Spark as well. And And then when it comes to Hadoop, in terms of cost, you can see Hadoop is cost effective, like it's somewhat cheaper when compared to the Spark. Basically, all the computation and the whole of the big data is saved within the hard disk. So we just have a cluster of this hard disk at different locations, and then we do the computation based on this secondary storage. But when it comes to Spark, you should definitely have a setup of RAMs, like for the in-memory computation, we definitely require more amount of RAM. Let's say if you're having 16 GB of RAM in my laptop, but to process 100 GB of data, so it will take a lot of time. So if I have more RAM than the data, then it will be very easy to resolve the data problem. And then when it comes to data processing, Hadoop primarily does the data processing with the help of batch jobs. Like it has jobs scheduled at regular intervals, where it will take the data from one input stream and then process the data and then push the data into some other secondary storage device. But whereas Spark is like interconnected with, integrated with cloud as well as different cluster of machines. It's like best of both worlds. And Spark also supports the batch jobs, but the extra thing in the slide is Spark supports the real-time data processing. So let's say if you are getting a stream of data from data lake, so in that case Spark can easily handle the stream of data. And then in terms of security, like Hadoop is more mature technology, so it is there in existence since 15 to 17 years. So it has more robustness in terms of security, like many different companies are using, and it has this Knox gateway, which provides a security layer for Hadoop. But when it comes to Spark, it recently gained popularity from 2015, I think 2013 to 15. So it spent some less time in the market, so it is somewhat not so secure when compared to Hadoop, which is a very mature big data framework. And in terms of fault tolerance, if you see, like Hadoop basically has this replication nodes for each master or main data node. It has a replication node. That replication node may not be an exact copy, but it replicates itself on a regular interval. So it has a slight delay in sync, but it is somewhat real-time sync with the replication node. When it comes to Spark, you can see we have this master-slave architecture. We also have this master-slave architecture even in Hadoop as well. This is just based on the implementation, but both of the frameworks support the master and slave architecture. So in this case, if you see here, we have a master, but if there is any crash, then the slave nodes will go into voting process, kind of master election, and then replace the original master in case of a failure. That can be a natural disaster or any server maintenance or server downtime.
Nowadays we are listening like most of the time we are hearing this data science life cycle is evaluating technology now. And in this, the first we will see the topic expertise. That means this data and the science are two different like knowledge things are combining to form a data science. So this topic expertise is like in healthcare system or in educational system, or else like so many different like technologies that people will be expertise on their own thing, and after that data acquisition step. In the initially, for anything we have to analyze and we have to do reports or something. First we want the data. So here in our project we are taking the data from WHO website. It's an official government website where all the countries' data they'll put there. And to know our mortality rate and how the health conditions are affected by like because of some reasons, we are first data acquisition step we are doing there, and after that data preparation. In the data preparation stage, we do the cleaning of data and like ETL transforming and loading into the next step. What is data exploration means? Here the mainly we are using the algorithms like clustering, classification and all, and the model evaluation. The final step is deployment. This is the life cycle we are going to use in our project. And the next.
So normally we usually hear about SDLC or STLC, software development lifecycle or software test lifecycle. But there is something new emerging nowadays, like data science lifecycle.
Even here the same flow also we also followed. We got the source plan from so many different sources because ours is the World Health History. So we are getting all the source files from different countries. So all the files we are merging with the using a Python code and making into a single merged file. So then after that file we are loading into the Spark RDB, and after loading that we are pre-processing that data. Once that here pre-processing means like removing of null values, and that another thing what we did is like unnecessary attributes we are took off from the data because those attributes are not useful for our analysis, so we have taken out that. And the explorated data analysis, the main data analysis here we did with some statistical methods. We have find out the data analysis and then modeling. The final result is like what we got is it gives the visualization thing, like how the entire data is affecting like
The major insights in the data, that's the final output as part of this project.
Data gathering, we gathered data from WHO websites, and after that we did data statistics on that. And how we combine files, as already I explained, we have combined with Python code. And one challenging thing we have faced in this project is like we got the data like deaths and the age of the persons. But what we did is like we did the binning of data. Like we have taken an interval of 0 to 5 years of age into one column and 5 to 10 years into another column. Like that till 100 years the life expectancy of the persons. We have divided our data into binning. The main reason we did binning is to get the good analysis of the project. These are the source files, we got it from the different sources and we have merged using a Python code, and finally we have taken this huge file. It is almost, if you see, 650 MB of file for our project analysis. Here almost we have a 6 millions of records, so only Hadoop or Spark can handle this, and the conventional methods like MS Excel or the other Oracle or these cannot handle this much big data. So even sometimes system may get crashed because of the huge amount of data. So we are going with Spark here. And the what kind of data we have faced is we have both the qualitative data and quantitative data. Qualitative data is the one thing where we can get only information regarding the discrete values, the characteristics, where we cannot do any calculations, whereas here we can do the calculations also. So these both the type of data we have in our data set.
Yeah, primarily when it comes to quantitative data, as we know, this is something like numerical data, something which can be measured, like let's say the weight of a person or the area of a room. All this come under continuous data types, but when it comes to discrete, it's like something which can be broken down into a number of items. It's like you can say maybe a count can be discrete. And then the qualitative data. Qualitative data is something which is in the form of categorical data, and data which we can order it. Let's say the weekdays, Sunday, Monday, Tuesday, Wednesday. So we can order that in a specific order. But when it comes to names, all the names are they don't have any particular order, but they are just nominal. So this is about the data types.
And these are the discrete data. We have the country and the cause, and the continuous data we got it like death 1 to 26 means like age, as we said we did the binning. Death 1 is the 0 to 5 years of age. Death 2 is that column is the 10 to 15 years of age. Like that we got the till 26. That is the binning we did there. And the next one is like IM deaths is like infant's death, like where it is like months babies are data. And this nominal is 6 and ordinal, these are the data types we have taken in our data set.
Yeah. In our data set totally we have like somewhere around 39 to 40 columns, among which 26 columns are regarding the total deaths. So these are the binned columns, like the bucketed columns. And then this is the infant deaths. We have 4 columns for infant deaths, and this is format, IM format. And these are all the other attributes just aid in our program, but some of them don't play a major role, but they are just there. So which will be eliminating going forward.
We did even data wrangling, means first we did the cleaning of data, then pre-processing and removing the null values, removing the outliers, means which we are not required, those data fields we have removed it. And after that, we have seen some missing attributes also, so we cleaned that using these methods. And streamlining of data, we, like where we have some float data, we have made it into an absolute value. And finally, the sorting of data we did, so that we'll get the good report.
Yeah. Again, data wrangling is just another fancy name for data cleaning. Both are almost, both do the same thing. And one more major challenge which we came across in terms of data wrangling is the mapping of values. So in our data file, we generally have the country codes available. So we need to map these country codes to the country names available in the internet. So that was one of the challenge. We spent a lot of time. Yeah, took a lot of time.
And finally, like what are the exploratory data analysis we got it? This is the one of the steps we have discussed in the front slides. So here, what main intention is ours is like showing the max depth of top 10 by country wise. Like then after that, we have seen that from 1955 to 22, how the deaths are happened, whether it's increased or decreased, based on what factors it all increased and decreased. And the infant deaths, how it is all like infants, how the death rate is controlled by then after that, top 10 diseases we have find out through this analysis. And the obesity also, it is a major factor affecting the world. And accidental deaths, how it happened from 1955 to 22. This all the report, we got it from this exploratory data analysis.
Okay, so we have visualized the data from the datasets. This is a bar graph that has the names of countries on the x-axis and the number of deaths on the y-axis. So, as you can see, USA tops the list. And then, okay. Okay, so we have some Russian Federation as well as USSR because of the difference in timelines, because we know it was earlier USSR and then they found Russian Federation. Okay.
And basically this chart is right from 1950 to 2020. So all the data is grouped and clubbed under the country names here. And then you can see that US has nearly 350 million casualties over a period of 70 years. And
in this, actually we clubbed USSR and Russia to see if we kind of find it interesting to compare Russia and USA because of the regular tensions. We compared it and then we found out that USA still tops the list. So, and so this in this chart we have visualized again x-axis.
One can
we have,
So
the
do
times.
you guys count the COVID-19 deaths?
Yeah,
Just
here it is
220.
like again spike in 2020.
There is no difference between 2018 and 2019.
Yes, because of there in 2018 some like in this
Oh,
period-
they still did not have the
yeah,
data
basically
yet.
we don't have the data for
Complete
whole
data.
We have partial data.
It's,
So if we have the COVID-19 data, then the spike will be
it's a 1
much
million
different.
difference.
But here little difference we can see after 19 to 20.
So what's going on between 1980 and 2000?
So you can take a guess. You can take a guess.
Anyone can guess it.
Plague, huh?
Okay, so
Any
I'll
plague?
break it down for you guys.
I have no idea.
Any
Okay.
plague?
Russia, USA was at war with
Oh,
Iran
Russia.
Iraq.
and
Wow.
Iran, and there were a lot of tensions between USA and Russian Federation.
Cold War was good.
అట్లా అనమాట
Can we look at the Russian
క్యాప్టెన్
data?
క్యాప్టెన్ అమెరికా
We have only US data.
Alright.
Yeah, but we can do the same for Russian data.
Okay.
So, and a lot of viruses were reported. There are no enough treatments of
Even
viruses.
medical technology also, it's
20
not
minutes.
that improved in 1990s when it comes to
నేను ఇది
2000s,
పెట్టుకుని
so many
చదువుకుంటూ
medical
ఉంటాను అక్కడ.
technologies became-
Presentation.
computerization of operations and all.
So the Iraq war actually killed more people than COVID-19.
Actually, it is only 2020, last 2 months was affected.
Oh, okay.
Basically, if you see here, we can
That's
see
that's
a,
from the year 2019.
Yeah.
Alright, so
yeah, we can see a linear trend here up to 2020, but you can see this is somewhat different, and actually we have some gradient curves going on here, like the yellow representing the highest peak
7 million.
peak count, and then the violet representing the less count here. And especially during this period, we had the Russian Cold War as well as the Vietnam War. All the geopolitics has been going on in United States. So that was a major contributor for this spike in deaths.
okay. So obviously after 2000, people are dying faster in the United States. Did you guys find
Doubt
out
not
the
added.
reason why? So compared
డౌట్
to
ఉంటుంది
like
ఇసం
So
తీసుకొచ్చి
because
కూర్చోబెట్టినా
the overall population of the
ఇసం
world
తీసుకొచ్చి కూర్చోబెట్టినా
what?
The overall population of the world is increased.
Oh,
It
Hey,
has-
awesome.
we have more people.
Yeah, some more deaths. That's
Okay, keep going.
okay. So
Okay.
this chart shows the infant deaths over time. We can see that there has been a high number of deaths starting from 1950 to around 1965.
నాకు చంపేశారా
This we found out that after some research on the internet, we found out that
Immunization of,
Yeah.
immunization.
we did not have a lot of vaccines for kids.
Okay.
For example, for tuberculosis or polio and many other viruses that were kind of affecting, and the medical industry also was not really up to the
Yeah,
mark.
and you can see that the COVID-19 actually does
In
not
fact, it is
affect
death.
the infant adults.
And then after that, it has been like little ups and downs, but it has been
It's
studied
it's
through.
like government took control over the infant deaths there, and it has implemented so many
Very good.
systems and the process, so that's why it got reduced.
Yeah, basically there has been upgrade in the healthcare system as well as modernization of the healthcare system as well as vaccines were supplied very well, and also government gave many funds and sanctions to improve the healthcare and infrastructure of US government, US overall. So this is the reason that like why we see a major decrease in terms of infant deaths here. And you can see there is a linear downtrend, and going forward, I think so there will be better care to infants. And I just want to show you this thing like yeah, all these things are done with the help of Plotly. Plotly is again another Python library which is advanced library for data visualization. It supports all these smart features like we can save a screenshot, we can zoom in, we can pan, we can simply just crop our image with the help of the tool. We can just crop, like we can do slicing the data.
Depending on our requirement, like what data we want and which year we want and which country we want, like that.
Yeah, we can just splice the data, dicing, all these things we can do here. And it also supports the gradient covering, and this is just the code for Plotly to plot this graph. All this code is already available in the documentation of Plotly website. Just we need to import this and then just pass in the column names of our data set. And then the next graph is causes of disease. And actually this, in this graph, like basically what we have done is against the data set, we just filtered the United States data, and then on top of the United States data, we just segregated based on the causes and deaths. So causes in the sense, let's take an example, heart disease is a cause, and then the number of deaths associated with that particular disease. So similarly, we just drew this pie chart where we can see all the disease types, but this is not a good representation. Why? Because we are not able to understand what kind of disease is this one.
Only through the codes, when we see the metadata, we are getting to understand.
Yeah, you can see the highest percentage is B27. That is the. Let me open the official documentation. You can see B27. That is heart disease.
Okay.
We have tried, Professor, but it's like a lot of codes we have, so
Yeah,
we're not able
it's,
to.
it's okay. It's
So
okay.
we need to do a lot of mapping to get this data. So I think once we do that one, then it will be fine. But it will take a lot of efforts to do this one. But this is possible. And similarly, if I go through all the major diseases here, what we came across is all of the major diseases are related to heart and obesity.
Heart disease and obesity. Okay.
Obesity and cholesterol levels. So, in terms of health, like US is lacking behind, not lacking, let's say, but the major number of cases and cause of deaths are due to the heart diseases and obesity and cholesterol.
Yeah. It's gonna wrap it up.
Yeah. In terms of conclusion, like so this project particularly it gives awareness and insights with the data, like what kind of drawbacks or let's say what kind of representations we can get from the data, and then this will be helpful to many different organizations, let's say healthcare organizations or insurance companies or maybe governments as well.
Conclusion
So
slide
with
better.
the help of these, they can simply design and develop better healthcare and healthcare systems.
Lot of NGOs can also start raising funds,
Okay.
and
And ultimately, this adds a good benefit to society and awareness among people. So we can see just based on the infant deaths as well as the mortality rates, the deaths due to wars and accidents, all these things we can easily understand like in which direction we are heading to and in which direction we need to invest in terms of and how we can protect our people. So all such problems can be addressed with the help of this project. And this is the gist of the things what we have learned as part of this project. Like we did implement all of the project in Apache Spark, which I will be walking through the code now, and how we use the RDDs, resilient distributed datasets, and how we process data with Spark and loading data into RDDs, transformation, and all these operations to aid the transformation and visualization.
Yeah. Give me a demonstration on the part of Spark and Hadoop.
Yeah.
Demonstration of the code.
Yeah, basically we did not use Hadoop here, but we had used Spark here. Yeah. The first thing which we need to do is we need to download Spark from official documentation, like official website, and then set up the Spark home path. And then we need to have this PySpark API. So to install PySpark API, we just need to do this exclamation mark space. We can install PySpark, which will install the PySpark into our machine. So there is a setup part. And then comes the importing of packages, all the relevant packages, PySpark package as well as the PySpark.sql, which can trigger the Spark session. So we need this Spark session in which our data will be loaded. And as you can see, I'll just show you the task manager. Yeah, I think so. It's not running, but in case if I run the whole project, my RAM utilization will go drastically way up. Now you can see the VS Code is utilizing somewhere around 900 MB but it will go to 5 GB, 6 GB as well to process this huge file.
Can you quickly go?
Yes. Yeah, this is the place where I'm importing my merged CSV file into the RDD data frame of Spark. And then this is these are the inferential statistics which I'm doing on ILR to understand what kind of data and how we are encountering the data, like the counting type of the data, columns, head, and then in terms of data wrangling, I'm selecting specific data as well as so I don't want all the columns, right? I needed only particular columns for my visualization purpose. So I'm not using all the columns every time. So why? Because and that too, my data set is very huge. So we don't want to go with all the columns. We will be removing few columns. This is the data, data frame dot describe. This data frame is again a Spark RDD data frame. And I'm just trying to check whether all the things which I input is working fine or not. And this is some syntax.
So basically, you guys just use the predefined functions in Python to look for some data, do some calculation, and visualize the result.
No, we did use Spark as well, yeah. But mostly PySpark libraries.
Yes, still you call all those predefined functions, right?
Yes, yeah, we did use all the predefined functions.
Okay.
Like basically directly from the PySpark library, from the documentation we got all these things. So we did explore all these methods. Like how to add a column, how to drop a column, how to rename a column, removing null values based on different criteria, like based on the columns or records, rows. Dropping null values from a subset of columns and then filling null values. Sometimes for a few columns we came across the null values, like the blank values, we just fill them with zeros, but we can also fill them with some average value as well. If we wanted, we can do that.
Pre-processing of data.
Yeah, all these things comes under pre-processing.